Okay, class, today we are going to look at our Chapter 3 STAR quiz, and this is just going to be our practice that we can work on. And so we're going to start with our first equation, which says that the output is equal to negative 3x plus 14. And it also tells us that our output is 29. So this variable, this output variable, is 29. And we're going to take this information and substitute it into our equation. So we're going to end up with 29 equals negative 3x plus 14. Now from here, you're going to subtract 14 from both sides. And you get that 15 equals negative 3x. So if 15 equals negative 3x, then x equals negative 5. Again, if 15 equals negative 3x, then negative 5 equals x. On number 2, it's asking me to graph a linear function. So I already know that this is going to be a straight line. It says x plus 2. So we need to look at our two things. We're going to look at our y-intercept, and we're going to look at our slope. Our y-intercept is 2. Our slope is 1 in front of the x. Is 1 in front of the x. So our slope is 1. So I'm going to look for my options. I see this option here is at negative 2. And I know that my y-intercept is positive 2. Down here again, I see my y-intercept is negative 2. So neither of these answers can be true for me. When I look at this, I see that I'm at positive 2. And I'm at positive 2. Both of these seem like they could work. And we see the major difference here is one is trending upwards and one line is trending downwards. To know what to do here, I look at my slope and I see that my slope is positive, positive 1. So that means that I need to be trending positive and not trending negative. So I know that this one fits the bill the best. It's got a positive slope, and it's got a plus 2 for a y-intercept. All right, and lucky for us, number 3 is a very, very similar problem. So we can go with the same process and write out our y-intercept and our slope. Again, our y-intercept here, plus 2. Our slope is negative 1/3. All right, so some good hints here. We know we're looking for a line that crosses through positive 2. This crosses through positive 2. This crosses through positive 2. Both of these could be our answers. This crosses through negative 2. This is negative 2. So neither of these can be our answers. Let's look at our next clue. Our next clue says the slope is negative. So this line is trending down to the negative. This line is trending up to the positive. So to match it up, a negative slope with a negative slope This means my answer should be A. And on number 4, again, a very similar problem to what we just looked at. The difference here is that we do not have a lonely number, a constant out here by its side. So I'm going to write mine in so that I have my y-intercept and my slope easily identified. My y-intercept has to be 0. My slope has to be the number in front of my x here, which is a -2. So let's look for our 2 clues. I see a line that goes through 0. This line goes through 0. This line goes through 0. This is through 0. And this is through 0. Not much help there. But if we go to a slope that is negative, I can see this slope is negative. This slope is positive. This slope is negative. And this slope is positive. So because I have a negative, I know that C and D are not the right answers. I've got a negative slope here, and we're looking for a number that means -2. So in this example, I go down 1, and then I go over 2 places. Down 1, and then over 2 places. And every time I repeat that cycle, down 1, over 2, I get to the line again. I get back to the line. Now over here, I'm going to go down 2. So down 2. And I'm going to go over 1. Again, I'll go down 2 and over 1 to get back to the line. When I do this, I think it's fairly clear. At this point, I'm going to match my number, -2 here, matches with my -2 here, because this is just -1/2. So this is not my answer, but this is. Good. Let's look at number 5. It says that we have a cost. We have a cost for apples. We're going to say that apples are X. And we're going to say that Y is oranges. So they give us our equation. 0.2 apples plus 0.3 oranges has to equal $4.20. So option A gives us 9 apples and 8 oranges. B is 3 apples and 12 oranges. C is 6 apples and 10 oranges. Then we have 12 apples and 3 oranges. So now we know that we're going to substitute our numbers into the equation to see and check if we get 420. So let's place and substitute this 9 and 8 into our equation. So for answer A, we've got 0.2 times 9 plus 0.3 times 8. And we're hoping we need it to match to this $4.20. So I need to put on 0.2 times 9 plus 0.3 times 8, and I get $4.20. So A is good for me. Let's talk about B. B has X of 3 and Y of 12. So here in my original equation, I'm going to put this X will now be 3. And I'm going to continue writing my equation until I get to a y. This y is now 12. We're going to hope that it equals $4.20. Let's see, we've got 0.2 times 3, and we have 0.3 times 12. All together, we got $4.20. This is looking good for us. So B also works. Let's look at C. C is going to have apples, and there are 6 of them, and oranges, and there are 10 of them. Again, we're hoping that we get up to $4.20. So we can say 0.2 times 6 plus 0.3 times 10, and that equals $4.20. That'll work. The very last one we have is 12 apples, 3 oranges. So let's check that. 0.2 times 12 plus 0.3 times 3. And I have 0.2 times 12 plus 0.3 times 3. And I got $3.30. So the question is asking me which one is not a possible solution, and this would be it. Okay. Number 6. Number 6 asks which equations are straight lines and which equations aren't. So I will have a linear function here, and I will have a linear function here. But whenever I have an x underneath, this is saying that my exponent has changed. Just like this is saying that my exponent for x has changed. When your exponent for x is not a positive 1, or 0, then it's going to be nonlinear. So you can't have B and you can't have D. And again, this is largely due, or one easy way to see it, is by looking at the exponents here. The exponent of y and x here are 1. The exponent of y here is 1. And these are all going to be linear. Now, number 7, it says, which questions have an answer of 4? So we're going to need to work out A, B, C, and D, and see which ones answer to 4. So A asks us the x-intercept. The x-intercept is where y equals 0. So in our equation, just like in the beginning, we're going to say 0 equals 3x minus 12. We're going to solve this for x and see if it is 4. So we can add 12 to both sides. And we get that 12 is 3x. So x, if we make x 4, 3 times 4 is 12. So x equals 4. And that's what we're looking for. So A is one of our possible answers. Let's go on to part B. Part B says the y-intercept. The y-intercept happens when x equals 0. So in this equation, we have 8 times 0 plus y equals 4. We know that 8 times 0 is 0, so y equals 4. And that's the number we're looking for. So I'm going to put on this that B is also a correct answer. Part C. Part C asks for the y-intercept. The y-intercept is where x equals 0. So we say that y equals 4 times 0 plus 8. In other words, y equals 8. And unfortunately, we wanted 4, not 8. So I can't pick C. Now let's look at part D, where it says the slope of y equals 4x minus 8. Now from our earlier equations, we know that this is the y-intercept, and the number in front of x is the slope. So here, the slope is 4. So 4 is the number I'm looking for. So D is also a good choice for me. All three of these answers will give me 4. Number 8 is almost the same question, but now they give us the function and have us solve it out for a specific number. So let's take our function of x minus 2y is negative 4, and let's list option A here. Option A is the x-intercept is negative 4. Well, the x-intercept is when y equals 0. So here I can say that y minus 2 times 0 is negative 4. X minus 2 times 0 is negative 4. So x equals negative 4. This statement says the x-intercept is negative 4. That is true. All right, so the graph of the function. The graph of the function. We have two different intercepts here. We know that the x-intercept is at negative 4. And this graph has us crossing the x-axis at 2. So if I have an x-intercept of negative 4, that should be right out here. But there's no graph out here. So this is not the graph of the function, because we know that the x-intercept has to be negative 4. Thank you, part A. No good on part B. Let's look at part C. Part C says the x-intercept is positive 2. The x-intercept is positive 2. The x-intercept, again, happens when y is 0. And we know the x-intercept is negative 4 and not positive 2. So it's not C. Let's look at part D. D says the y-intercept is 2. Y-intercept means x is 0. So our equation is x minus 2y equals negative 4. So 0 minus 2y is negative 4. Dividing by negative 2 means that y equals, we have 4 divided by 2, which is 2. We have a negative divided by a negative, which is a positive. So our y-intercept is at positive 2. And this says the y-intercept is at positive 2. So both of those answer options, A and D, are correct. Number 9 is talking about functions. And functions mean that x does not repeat. So all we need to do is look at our x-axis, and we come from here I'm only hitting the graph. When I go up from the x-axis, I can only hit the graph one time. So A is definitely a function. Now, a graph of something that is not a function would be like this. Because now what I can do is I can go to the x-axis here, 1, and if I go straight up, I'm going to hit the graph. That's 1. If I go straight down, I'm going to hit the graph. That's 2. This is x when it does repeat. So that's why this is not a true function for us. Because x is repeating. But here, x does not repeat. Here, x does not repeat. For every x value, you have exactly 1 time. So this is a function. Look down here. We have -7. We have -4. We have +4. We have +9. If x does not repeat, then it is a function for sure. Right now, where we are in our math learning. All right, last option is letter D, and we can see there's a -6, there's a -3, and there's 2 of them. There's a 0 and a 5. So if we wrote this out, it would be -6, -3, -3, 0, and 5. And then here, we would have 3, 4, 6, 8, and 10. All right. So here that repeat of -3s is what makes this not a function. This is not a function. Here, there were no repeats, but here there are. There's no repeats. There's no repeats. So anytime you see x repeating, this is not a function. All right, so up here we're going to say function. Down here, we're going to talk about linear. Linear. This is something different, and this means we're looking at common difference. And same, common, we mean same. It needs to repeat through the whole thing. So from -2 to 4 is add 6. From 4 to 10 is add 6. From 10 to 16 is add 6. From -14 to +2 is add 16. So again, you want to make sure that on this kind of stuff you're being very careful with your numbers. I have a -14, and if I add 16 to it, I will get to a +2. 14, that's negative, plus 16 is 2. But the distance from 2 to 10 is only 8. And the distance from 10 to 26 is 16. So because this is not different, we have to say this is non-linear. Okay, from here, let's look at the next one. Go from -1 to +4. That's a total distance of 5. So again, -1 plus 5 will get us to that 4. All right, from 4 to 9 is another 5. From 9 to 14 is another 5. From -4 to 11 is 15. From 11 to 26 and from 26 to 41. So these will all be 15. And now because these numbers are all the same, this is linear. Okay? And that's what we call finding the common difference. All right, our last problem is our real-world application problem. And it's got 3 quick parts. Essentially, you're a bicycle, and you're going to meet your friend on a bicycle. So they give us M for miles, and we get T for hours since noon. All right, since noon. So part A says make a graph first. So let's write our y-axis and our x-axis. Let's label. This is T for time in hours from noon. And this is M for miles. At time 0, when time is 0, we have rode our bike 0 miles, no miles. All right, so we have T and we have M of T. At time of 0, we have 0. But if we put in a 1 for time, like 1 hour, this is 1 p.m., 2 p.m., 3 p.m. If we put in a 1 hour, then we just need to take our equation and put a 1 inside of your equation. So M of 1 equals 11 times 1 plus 40. So we're just copying the equation down here. And instead of a T, I will put a 1. So M of 1 is 51. Now let's try M of 2. And now let's copy the equation. So M of 2 would be 62 miles. M of 3, let's copy the equation. So M of 3 is 73. All right, so it looks like we're going to ride quite a few miles today. And our time doesn't go out that far. So I'll do 1, 2, 3, 4, 5, 6, 7, 8. And this is since noon. So literally we're talking about 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5, 6, 7, and 8 p.m. On my miles, I go from 0 miles to 73 miles at hour 3. So at hour 6, we're going to be more than that. So I should probably do 30, 60, 90, 100, 30, 60. Yep. All right. So 30, 60, 90, 120, 150, 180, do 10. So we'll just count by 30s. And now let's place some of these numbers on. We have 0, 0 already there. Let's put a 1, 51, 2, 62, and then 3, 73. All right, we can draw our line out. And I'm not going to put any arrow markings on here because at some point I'm going to get tired and want to stop riding my bicycle. So I'm not going to stop the line. I am going to talk about the slope. So how do I go from 51 to 62? I need to add 11. And how do I go from 62 to 73? I'm going to add 11. And how do I go from 1 to 2? Like that. So it says interpret the slope. And so my slope is in my equation. It is 11 over 1. So here's part A. Here's my graph. And my slope. My slope is the number in front of the independent variable. So in this case, my slope has to be 11. And this is the y-intercept here. So we don't need this right now. I just need to know that this is not the slope, it's the y-intercept. This 11 is the slope. And it's 11 divided by 1. $11 is on the miles side. So this is miles. And 1 is on the time side. And we've been measuring time in hours. So when they ask me to interpret the slope, they're saying, I ride my bike 11 miles per hour. And that'll take care of part A. In part B, they go through and they tell you that the cyclist only rides until 6 p.m. So what's domain and range? Alright, well, if I just ride until 6 p.m., that means that when I hit this hour, I stop. So that makes my domain, which is just the x-axis, between 0 and 6, right? Because I gotta stop at 6, and I'm gonna start here at 0. So my domain is the x. And this domain is gonna say x has to be between 0 hours and 6 hours. That's where my graph starts and stops, is at 0 and 6. Now let's talk range. I actually don't know how many miles it is if I go for 6 hours. I don't know. So what I'm going to do is I'm going to use this equation, and I'm going to put 6 here for the time, 6 hours. So my range is going to say 11 times 6 plus 40. This is 66 plus 40, which is 106. 106 miles. How far you go? So if I start out at time 0, and time 0, let's figure out what that's going to be. It's going to be 11 times 0 plus 40. And so for us, we can see that our range at time 0 is just 40. So that's what we're going to do. We're going to say that at time 0, you've already gone 40 miles because it's noon. And after 6 hours at 6 p.m., you've gone 106 miles. All right, so in part C, it's going to ask us, okay, the cyclist meets up with friends from the morning starting location, from the starting location. So that was even back here, right? Because we started this graph at noon. This is hours from noon. So noon is here, and at noon, we had just driven 40, we had just rode our bike 40 miles. And then we go 11 miles an hour, 11 miles an hour, 11 miles an hour. Over 6 hours, we get up to how many total miles? Now I'm not just talking this distance, I'm talking about since morning, since like when we started back here, since morning. Right, because this is noon, this is 1 p.m., 2 p.m., so I'm talking about like 10 a.m., 9 a.m., that kind of thing. So how many total miles would that be? Okay. Well, we know from our equation that we have driven 40 miles. Before we even started, we've driven 40 miles. Then, we go from 6 hours. So altogether, we have 66 plus 40 miles. And we know from our last problem, that gives us 106 miles. But our friends are at 120 miles. So if we started all here together, here's where time 0 we started. We did our bicycles throughout the morning. There's that plus 40 that we see in our equation. And then from there, this is noon. This is noon. So from here, we go 11 miles an hour, and we do that for 6 hours. So we go 11 miles, 22, 33, 44, 55, 66. There's 66 more miles. So altogether, we came out at 106 miles. And our friends are out here at 120. So the question is, will the cyclists get there to meet up with their friends at 120 miles? And we can see that the answer has to be no. They're at 120, you are at 106. So how many more miles do you need to go? You need to go 14 more miles. No. You are 14 miles away from your